In the last few weeks, a claim has been spreading across the internet that sounds almost too strange to be true. After 48 years of silence, Voyager 1, the most distant human-made object in existence, supposedly turned its camera back around, aimed it at something out in the dark, and sent back a discovery nobody can explain. Videos are racking up millions of views repeating this exact claim. Comment sections are full of people asking what NASA is hiding. And here is the uncomfortable truth you deserve to hear before you watch another video about this. That specific claim, that Voyager 1 just turned its camera back on in 2026, is not true. But do not click away yet, because what actually is true, what NASA's own scientists are on the record admitting they cannot fully explain, is in some ways stranger and more important than the myth currently going viral. Stay with me, because by the end of this, you will know exactly what is fake, exactly what is real, and exactly why a 49-year-old spacecraft with no working camera at all is still delivering one of the most genuinely unresolved mysteries in modern physics. Let's deal with the myth first, because you cannot understand why the real story matters until you understand exactly where this confusion came from. Voyager 1's camera has not taken a single photograph since February of 1990. On Valentine's Day that year, at the request of the astronomer Carl Sagan, mission controllers turned the spacecraft's camera around one final time and pointed it back toward the solar system. It was leaving behind, capturing a sequence of images that became known as the Solar System Family Portrait, including the single most famous photograph in the history of space exploration, the pale blue dot, a single pixel of light suspended in a sunbeam that Sagan later described, in words that still circulate today, as everyone you love, everyone you know, everyone you ever heard of, on a mote of dust suspended in a sunbeam. That was the moment Voyager 1 turned its camera around. Not last month, not this year, 36 years ago, before most of the people currently watching viral videos about it were even born. Immediately after capturing those final images, mission controllers deliberately shut the camera down permanently, and here is the detail that makes the recent viral claims especially misleading. They did not just power it off, they physically removed the flight software that controls the camera system from the spacecraft's onboard computer entirely, repurposing that limited memory and processing power for the instruments engineers actually needed for what came next, the long, unprecedented journey into interstellar space. NASA has been direct about this whenever asked. Even if mission managers today wanted to turn the cameras back on, they would first need to recreate the ground computers capable of understanding the camera's software, a system that no longer exists anywhere in usable form, then reload equivalent software onto a spacecraft currently 13 billion miles away, with a round-trip communication delay of nearly 2 full days. And even after all of that, there's no guarantee the cameras would still function at all after sitting exposed to the extreme cold of deep space for nearly 4 decades. And even if, against every practical obstacle, the cameras somehow did work, NASA's own scientists point out there would be almost nothing worth photographing. It is extraordinarily dark where Voyager 1 currently sits, far beyond the reach of meaningful sunlight, and the same distant stars visible in any hypothetical Voyager photograph are already visible in far greater detail through ordinary telescopes here on Earth. Turning the camera back on would not just be difficult, it would be, in the most literal sense, pointless. So why is this myth spreading right now in 2026 with such force that it is generating millions of views? Part of the answer is simply the nature of how information travels once a compelling image gets separated from its original context. The pale blue dot photograph itself has had renewed attention recently, including a reprocessed anniversary version created by imaging specialists using modern software, and anniversary content about a genuinely emotional, genuinely historic photograph tends to spread quickly. Somewhere in that spread, the historical fact that Voyager 1 once turned its camera around gets detached from its original 1990 timestamp and recombined with genuinely current 2026 headlines about Voyager 1's ongoing mission, its dwindling power supply, and its scheduled milestones this year, creating a garbled, inaccurate composite claim that sounds new, even though every piece of it is decades old. This is exactly the kind of misinformation this channel exists to cut through, because the real story sitting underneath the myth is more than compelling enough on its own without needing to be exaggerated. Here's what is actually happening with Voyager 1 right now in 2026, and here's the part where the phrase discovery we cannot explain becomes completely verifiably accurate, not clickbait. Starting in 2017, the plasma wave instrument still operating aboard Voyager 1, an entirely different piece of hardware from the long-dead camera, began detecting something that nobody on the mission's science team expected and that nobody has fully explained since. A persistent narrowband signal, a kind of faint but continuous hum embedded in the plasma of interstellar space itself, the charged particle environment that exists in the vast, mostly empty stretches between star systems. This was not a single anomalous blip that could be dismissed as instrument noise or a one-time glitch. It has continued, year after year consistently, across a stretch of interstellar space, now measuring hundreds of millions of miles, as Voyager 1 continues moving outward at roughly 38,000 miles an hour. Researchers analyzing this data, published in the peer-reviewed journal Nature Astronomy, described interstellar space as fundamentally more turbulent, more structured, and more dynamic than the models built before Voyager 1 arrived. There had predicted. To understand why this matters, you have to understand what scientists expected to find before Voyager 1 actually got there. For decades, the best available models, studiously known at describing interstellar space, the region beyond the protective bubble our sun creates around the entire solar system, predicted something close to a quiet, uniform, largely featureless environment, cold and sparse, where charged particles drifted slowly, with little happening on any meaningful scale. That was the theoretical picture built entirely from instruments here on Earth, telescopes and mathematics and inference, because no human-made object had ever actually been inside interstellar space to check whether the theory matched reality. Voyager 1 crossed into that space in August of 2012, becoming the first spacecraft in history to physically leave the solar system. And beginning in 2017, its instruments started telling us that the quiet, uniform picture built by all those decades of Earthbound modeling was simply wrong. Interstellar space, according to Voyager 1's direct measurements, has structure and texture at nearly every scale scientists have been able to check, from distances measured in mere meters all the way up to distances measured in millions of miles. The persistent emission itself has narrowed down to two competing possible explanations, and here is the genuinely honest part of this story, the part that separates a real scientific mystery from manufactured internet drama. Researchers currently do not know which explanation is correct, and they are saying so publicly in their own published work. The first possibility is that the signal comes from thermally excited plasma oscillations, essentially the natural vibration of charged particles interacting with their surroundings in interstellar space. This would be a significant and exciting discovery on its own, but it would fit within the existing framework of plasma physics without requiring any of the fundamental theory to be rebuilt. The second possibility is something called quasi-thermal noise, a distinct physical mechanism that would carry information about the density and temperature of interstellar plasma through a subtly different process, one that would require meaningfully revising existing models of how the interstellar medium actually behaves. Distinguishing between these two explanations requires either more data directly from Voyager 1, a resource that shrinks every single year as the spacecraft's dwindling power supply forces the mission team to shut down instruments one by one, or an entirely new mission specifically designed to study interstellar space with purpose-built instruments, and no such mission currently exists. None is currently funded. And even if one were approved and built starting today, it would take at minimum 25 years just to reach the same boundary Voyager 1 already crossed back in 2012. This is not the only genuinely unresolved mystery Voyager 1 has handed scientists in just the past few years. And the second one involves something that very nearly ended the mission entirely, in a way that connects directly back to why any of this data still exists for us to argue about at all. In 2023, Voyager 1 nearly went silent for good, not because of anything happening in the interstellar plasma outside it, but because of a single tiny hardware failure inside it. On for 5 months, the spacecraft continued transmitting a signal, but the signal itself had become unreadable, scrambled, gibberish that engineers at NASA's Jet Propulsion Laboratory, despite decades of experience reading everything the spacecraft had ever sent, simply could not decode. When they finally traced the problem, they found a single memory chip inside Voyager 1's flight data system had physically deteriorated after nearly 5 decades of continuous exposure to the harsh radiation environment of deep space. A piece of hardware, smaller than a fingernail, that had quietly failed after 46 years of non-stop operation. In any ordinary engineering scenario, you fix a failed component by physically replacing it. That was never an option here. The component in question was roughly 15 billion miles away, and the only available tool for diagnosing and fixing it was a radio signal that took 22 hours to travel one way, meaning every single test, every theory, every attempted fix required a minimum of 44 hours just to complete one round of communication. Engineers worked through that agonizingly slow process for months, eventually discovering that the corrupted section of code could not be repaired in place, but could be relocated, splitting the affected software into smaller pieces and rewriting each one to function correctly from a different section of the spacecraft's remaining memory. It amounted to a form of remote brain surgery performed across a communication delay of nearly 2 full days on a computer system originally designed using technology that predates the personal computer. And it worked. In the middle of 2024, Voyager 1 came back online, transmitting clean, complete, readable data once again, and what it immediately resumed sending was more of that same unexplained plasma signal that had puzzled scientists since 2017. more direct evidence of a region of the universe that has never once behaved the way our models said it should. Now here is where the story becomes genuinely urgent, because this is happening in real time, right now in 2026, and the timeline is tighter than most people realize. Earlier this year, NASA made a decision nobody working on this mission wanted to make. The low-energy charged particle instrument, one of Voyager 1's science instruments that had been collecting data almost continuously since launch in 1977, was switched off. Not because it had stopped working. It was still functioning perfectly. It was shut down purely because the spacecraft's dwindling power supply could no longer support it. Voyager 1 gets its electricity from radioisotope thermoelectric generators, essentially sealed containers of decaying plutonium-238 that convert heat into usable power as the plutonium slowly breaks down over time. At launch, these generators produced roughly 470 watts of power combined. Today, nearly 50 years later, that output has fallen to roughly 250 watts, and it continues declining by about 4 watts every single year, a slow, mathematically certain countdown that cannot be reversed, only carefully managed. Of the 10 scientific instrument packages Voyager 1 originally carried at launch, 7 have already been permanently switched off, each decision representing a genuine set of scientific questions that will now simply never be answered. But the team at NASA's Jet Propulsion Laboratory has not given up on buying more time. Engineers are currently testing an experimental procedure they have nicknamed internally the Big Bang, a coordinated, all-at-once reconfiguration of how power flows through the spacecraft's remaining systems, designed to squeeze extra operational years out of a supply that is otherwise guaranteed to keep shrinking. Because any attempt to reconfigure a spacecraft's power distribution risks triggering automated fault protection systems during the unstable transition between configurations. The team first tested this procedure on Voyager 2, which currently has a slightly larger power margin and sits somewhat closer to Earth, making a potential failure marginally less catastrophic. If those tests succeed, the same procedure is expected to be attempted on Voyager 1 no earlier than July of this year, carrying with it the genuine possibility that the recently shut down low-energy charged particle instrument could be reactivated. And with it, a renewed stream of direct data about exactly the kind of unexplained interstellar structure that has been puzzling scientists since 2017. There is also a real fixed milestone arriving later this year that has nothing to do with any viral rumor and everything to do with just how far this spacecraft has actually traveled. On November 18th, 2026, Voyager 1 will cross a distance of exactly 1 light day from Earth, a point so far away that a radio signal traveling at the maximum possible speed anything in the universe can travel will take a full 24 hours just to complete a one-way trip. No human-made object has ever reached that distance while still alive and transmitting, and Voyager 1 will do exactly that later this year, continuing to move outward at roughly 38,000 miles an hour, continuing to carry the golden record bolted to its frame, a message intended for whoever or whatever might eventually find it, long after the spacecraft itself is gone. Permanently silent sometime in the early 2030s, when its remaining power finally falls below the threshold needed to operate any instrument at all. So here is the honest, complete picture, laid out plainly rather than sensationalized. Voyager 1 did not just turn its camera back around. That happened once in 1990, and it will almost certainly never happen again, for reasons that have nothing to do with secrecy and everything to do with basic physical practicality. But Voyager 1 has, in the years since 2017, been sending back a signal from interstellar space that genuinely stumped the scientists studying it then, and genuinely stumps them still. A persistent structure in the fabric of the space between the stars that our best models insisted should not exist, and that researchers, in their own published, peer-reviewed words, still cannot fully explain. That mystery is real. It is ongoing. It is happening right now, transmitted across 15 billion miles in 22 hours of travel time from a machine running on less electricity than the light bulb in your refrigerator, built using technology that predates the internet, that was only ever supposed to last 5 years, and that instead just kept going, past every expectation, past a near-fatal hardware failure, past 4 decades of dwindling power, still listening, still transmitting, still handing us questions about the universe that nothing else humanity has ever built is currently positioned to answer. The myth says Voyager 1 turned around and found something impossible. The truth is stranger and more honest than that. Voyager 1 never needed to turn around at all. It has been staring straight ahead into genuinely uncharted territory for nearly a decade, and what it found there is still, right now, an open question in modern physics. If you want to know what happens when the Big Bang power procedure is finally attempted on Voyager 1 this July, and what that could mean for reactivating the instrument that might finally help settle this mystery, subscribe and turn on notifications, because the real story is still unfolding, and it deserves to be heard exactly as it actually happened.